This is a virtual poster presentation titled Simulated Thrombosis Patterns in HVAD Depend on the Axial Clearance Gap and One Willebrand Factor Activity. I am the presenting author, Mansur Jusupekov. I have no disclosures. We have previously presented a numerical study on the platelet deposition patterns within the blood lubricated bearing region of the HVAD. As you may know, this pump relies on both magnetic and hydrodynamic levitation. Previously, we assumed the axial gap distance between the top of the impeller surface and the pump housing to be 50 microns. However, a recent experimental measurement by Thamsen and colleagues revealed that the gap in the HVAD is a strong function of pump speed and fluid viscosity. At 4 centipoise of viscosity, they found that the gap can vary from 18 to 28 microns as a function of RPM. This is almost 2 times smaller than we had previously assumed. That's why the current study investigates the influence of the axial clearance gap on the simulated thrombus patterns. We're also testing our recently developed one Willebrand Factor mediated platelet deposition model. Our thrombosis model includes platelets in resting and activated states that can deposit on surfaces and can aggregate to form larger clots. At the same time, platelets can be cleaned off by the action of the shear stress. A more detailed mathematical description of this model can be found in the original publication by Wei-Tao Wu. A more recent development is vWF-mediated deposition model, where the presence of vWF in an unfolded form increases the resistance of platelets to shear cleaning, enabling deposition in high shear environments. This model is an Eulerian model, which means we solve convection diffusion reaction equations for the platelet species and biochemical agonists. We simulated this pump at 2 operating conditions, pediatric and adult, which we took from Graniger et al. 2020. However, in this presentation, I can only present the first half of this work. We fixed the axial clearance gap at 25 microns and used a frozen rotor simulation approach. At this stage, there is no turbulence modeling. This is the CFD mesh that has 6.2 million cells, and at pediatric operating condition, we obtained a pressure head of 56 millimeters of mercury, which is close to the value reported by Graniger et al. 2020. The key point on this slide is that as the blood is driven into this wedge-like converging section, the pressure grows so high that apparently a flow reversal takes place. The flow changing direction means that there is a stagnation line or stagnation region in which shear stress is almost zero. Again, this is at 25 micron axial distance gap. When we run the thrombosis simulation, unsurprisingly, platelets are able to deposit in this low shear zone. This is after 30 minutes of simulation time, and I'm calling this a baseline simulation, since I'm using platelet deposition and shear cleaning rates for titanium alloy from the original model validation paper. When I activate the vWF bond strength function, the platelets are now much more resistant to shear cleaning. Hence, the deposition shifts to the high shear zone, and it happens at a much earlier time point, 4 minutes versus 30 minutes of simulation time. This means that the platelets are able to form a high shear clot much earlier than they aggregate in the low shear stagnation zone. This work is very much a work in progress, but so far we have seen that the reduced axial gap can drastically alter the hemodynamic conditions within the blood lubricated region, which drives the platelet deposition in the stagnation zone. Activating the vWF function shifts the initial deposition to the high shear zone, and this happens at a much earlier time point. Ongoing work expands this study to a wider range of operating conditions with corresponding axial positions of the impeller. I would like to acknowledge our funding source and thank Dr. Bente Thamsen for sharing their CAD model of the HVAD. This allowed us to correct some of the features that we missed in our own CAD reconstruction. We are grateful to our clinical partners for the HVAD explant images. Thank you for listening, and I hope you stay safe and healthy in this time.